As we start to look at the Polygon Angle Sum, we're going to look at this table to see what kind of patterns develop whenever we're looking at the angles of a triangle and different polygons as we go on. So the basic one we know first is a triangle. So a triangle looks like that, has three sides, and a triangle has one triangle in it. And we do know that the sum of the interior angles is 180 degrees. So that's what we come in with knowing. So now let's think of a quadrilateral. If I drew one diagonal in a quadrilateral, it's going to have two triangles. And then we could say, well, 2 times 180 gives us a total of 360 degrees. So the sum of the interior angles of any quadrilateral will always be 360 degrees. But what if we had a pentagon? I'm going to draw a little bigger off to the side here. In our pentagon, if I drew diagonals from one point, I'd have 1, 2, 3 triangles. 3 triangles, 3 times 180 gives me 540 degrees. Let's go to a hexagon. Hexagon has 6 sides. From one point, I draw my diagonals, and I have 1, 2, 3, 4 triangles. So that's 4. 4 times 180 is 720. So now let's think of if there's a pattern that develops and if we can find a general rule. And that's what we mean by n-gon. We don't mean like there's a certain number of sides. It just means if it was any polygon with n number of sides, you pick the number, a rule we can come up with. So I notice whenever I have the number of sides, the number of triangles is always 2 less than that. So that means if I had n sides, I would have n minus 2 triangles. Then we took the number of triangles and we multiplied it by 180. So we could do n minus 2 times 180 to get our new total. And that's what actually gives us the sum of the interior angles. N minus 2 times 180 is that sum. You could also write it as 180 times n minus 2. So that's an important rule we have first. So that's the sum of the interior angles of any polygon. If we know the number of sides, you substitute that in, you're going to subtract 2, multiply by 180, you get the total. Now what if it's a regular polygon? In a regular polygon, all the sides are the same. If all the sides are the same, all the angles would be the same. So the sum would be n minus 2 times 180 divided by how many sides or how many angles you have. And so that'll give us, if a regular polygon, what each angle would be. And we'll kind of see that as we solve some problems. Then we go to the exterior angles. The sum of the exterior angles is always the same value. If we look at this, so it's 180 n minus 2. If I distribute that out, it gives me 180n minus 360. Well, this isn't multiplied out, but let's think of this is another context. So if I had this triangle right here, there are 3 sets of supplementary angles. So those supplementary angles multiply to be 180, or add together to be 180 degrees, and I have 3 of them, so that could be 180 times 3. What happens when I find the interior is I subtract 360 away. Well, what I'm actually subtracting away is these outside parts, which are 360 degrees, which leaves me with my total. I could do the same thing here. I have 180 times 4 is all of these, but to find the interior, I subtract 360 away, and it leaves me with my total. So the sum of the exterior angles is always 360 degrees. Regardless of the number of sides, it's automatically 360 degrees. Now, the sum of the exterior angles for a regular polygon is we're going to take that total, 360, and just divide by how many sides or angles that we have to give us the value. So these are the formulas we use. Now we'll go through and solve the problems. We just need to make sure we're picking the correct formula as we're solving. So find the sum of the interior angles of a 15-gon. So we want the total for the interior. So this is going to be n minus 2 times 180. 15 is this number of sides. 15 minus 2 times 180. We're going to subtract first. So that's 13 times 180. And that gives us 2,340 degrees. For the next problem, we need to find the value of x. So first off, we know this is a quadrilateral, and we don't really need to do the n minus 2 times 180, because we're just going to learn to recognize that a quadrilateral is 360 degrees. But we got 79 plus 110 plus 55 plus x has to equal that 360. So I'm going to do 79 plus 110 plus 55 gives me 244. I'm going to subtract 244 from 360, and that leaves me with 116, which would be this angle. For the next problem, what is the measure of each exterior angle? So we want the individual exterior angles of a regular hexagon. So that's going to be the outside angles that we're looking for, but we want each individual angle, not the sum. So we know the total is 360 degrees. We know in a hexagon, n equals 6, so that's going to be 360 divided by 6, which is 60 degrees. Meaning if I drew a hexagon and extended, so they're all the same angle, all of those extended angles out, those exterior angles would be 60 degrees. Next one, if an exterior angle of a regular polygon measures 12 degrees, how many sides does the polygon have? So this is taking this problem and solving it backwards. So 360 over n is what we're using. We know 12 degrees. So if I multiplied n to the other side, and I'd have 360 degrees equals 12 degrees times n, and then divided 12 back, I get 360 over 12 equals n. That gives me that n equals 30, so there's 30 sides. For the next problem, what is the measure of each interior angle in a regular 18gon? So each interior angle, we're going to do 18 minus 2 times 180 over 18. So it's the total divided by how many we have of each. So we're going to go 16 times 180 over 18. And that gives us 2,880 divided by 18. And we get an answer of 160 degrees. For our next problem, this is a 5-sided polygon, so that is a pentagon. So 5 minus 2 times 180, or 3 times 180, gives me 540. That's the total of all of these angles. So we're going to say 540 equals 87 plus 105 plus 135 plus 92 plus x. So we need to find the missing value that completes it. 87 plus 105 plus 135 plus 92 is 419. And we now do 540 minus 419, and it gives us 121. So x is 121 degrees. For our next problem, we have 1, 2, 3, 4, 5, 6, 7 angles. This would make it a heptagon. So we're going to do 7 minus 2 times 180, or 5 times 180. And that gives us 900 degrees. So we're going to say 900 equals, we'll start here, 136 plus 140 plus 148 plus 90, don't forget the 90, plus 150 plus 142 plus x for solving. So we got 136 plus 140 plus 148 plus 90 plus 150 plus 142. We have that 900 equals x plus 806. So 900 minus 806 gives us that x is 94 degrees. Next problem, we have 1, 2, 3, 4, 5, 6, 7, 8 So we're going to do 8 minus 2 times 180. That's 6 times 180. Gives us 1080. So we're going to go 1080 equals 129 plus 132 plus 136 plus 124 plus 141 plus 158 plus 116 plus x, and we're going to solve it the same way. So we get 1080 equals x plus 936. So now 1080 minus 936, we get that x is 144 degrees. Next problem, if the exterior angle of a regular polygon measures 40 degrees, how many sides does the polygon have? So the exterior we know is always 360, and if it's regular, we can divide by number of sides, and that's what 40 degrees is equal to. Or meaning if we had this polygon, this is 40 degrees, but all the sides are the same, we need to figure out what value of n works. So I could do 360 equals 40 times n, then that becomes 360 over 40 equals n. 360 divided by 40 gives you that n equals 9 sides. Last problem, if the interior angle of a regular polygon measures 108 degrees, how many sides does the polygon have? I'm going to show you two ways you could solve this. So first off, let's use the rule. So 108 is equal to what each angle for the interior is. So we're going to go n minus 2 times 180 over n, and we're going to solve for n. First thing, we're going to multiply over n to both sides, so I get 108n equals n minus 2 times 180. By distributing it on the right side, we get 180n minus 360. I'm now going to subtract the 180 to the left side, so that's going to be 108 minus 180. Which gives me negative 72. N equals negative 360. So now it's n equals negative 360 over negative 72. So negative 360 divided by negative 72 comes out to be positive 5. So there's 5 sides. Here's another way we could do this one. If the interior angle is 108, the exterior angle would be 180 minus 108, which is 72 degrees. We know they're all the same, so 360 over n equals 72 degrees. That becomes 360 over 72 equals n after we move it around like we were doing on the previous problem. So now it's just 360 divided by 72, and n equals 5 sides. It's a little bit different way, but it requires you to understand the relationship between the interior and exterior, and the fact that the exterior rules are a little bit easier.